Welcome to solverfy.
Hello. In this question, we have three compounds to name, three organic compounds, and what we notice in each of these, we see COOH. Or in other words, these are all carboxylic acids. And this is important to know because that tells us that the end of each of our names is going to end with the suffix oic and acid. That is how carboxylic acids are named. These are also known as organic acids. So let's go ahead and get started. We have a benzene ring in letter A. With the functional group that makes it a carboxylic acid attached here, and then a chlorine attached over here. So when we name this, again, we know that it's a carboxylic acid, so it's going to end with oic acid. So we need to name what is attached to the carboxylic acid. So that is a benzene. So this becomes benzoic acid. But we're not done yet because we still need to name the chlorine group that we see here. So if the carboxylic group is attached to the first carbon in the ring, the chlorine is attached to carbon number 4 in the ring. Regardless which way we number going around this ring, it's still going to be on carbon number 4. So we need to name that also, and that is on the 4th carbon, so we have to give it an address, and then we use the root of its word chloro. So what we get is 4-chlorobenzoic acid, and that is the correct name of this, 4-chlorobenzoic acid. Let's move on to letter B. In letter B, we see, so I am just doing the skeleton structure of these until I get to the functional group so that we can see that it is in fact a functional group. Okay, so let's see what we do have here. Again, it's a carboxylic acid, so it's going to end with oic acid. We need to see how many carbons are in the longest continuous chain. This doesn't necessarily mean a straight chain. We're looking for the longest continuous chain. So starting with the carbon that is in the carboxylic acid, the longest continuous chain is the one that I just highlighted there. In other words, it's 1, 2, 3, 4, 5, 6 carbons in length. So that is a 6-carbon chain. If it were just a hydrocarbon, it would be hexane. So this is going to end. We're going to take hexane. We'll take the E off the end and add our oic acid. Okay, so by writing hexanoic acid, I have taken care of the functional group and the 6-carbon chain. But we still have a couple of branches here. We have a 1-carbon branch coming off of the 2nd carbon and a 2-carbon branch coming off the 3rd carbon. 2 carbons, we know the prefix is F. And since it's a substituent coming off here, it's going to be an ethyl. And 1 carbon is meth, so this is going to be a methyl. And then we just need to supply an address. The methyl comes off the 2nd carbon, the ethyl comes off the 3rd carbon. We know that we have to put these in alphabetical order, so we're going to write the ethyl first. So its address is 3 because it comes off the 3rd carbon. So 3-ethyl, and then coming off the 2nd carbon, is the methyl. So it's 3-ethyl, 2-methyl hexanoic acid. That's our final answer. Okay, so you notice that naming these is really just going in order and making sure that we're naming each part of the molecule. This last one's pretty easy. We just have a C double bonded to an O, to an O, to an H, and I'll even put in the other H here. So there's only one carbon here. So a 1-carbon hydrocarbon would be methane, but we see this is a carboxylic acid. So this is going to start like I'm writing methane, but instead of putting the E, I'm going to put oic acid. So this is methanoic acid, the carboxylic acid that just has 1 carbon in it. Final answer. All right, thanks so much for watching.